Let us start with the solution of problem number 5, where the weight of the electric motor is given as 125 kg and it runs at 1500 rpm. The most important thing about this particular problem is the transmissibility. Here the question says that the transmissibility TR is equal to 1 by 11th. So the equation of transmissibility can be written as 1 divided by omega n square minus 1 when we consider epsilon to be negligible. Only in this particular case condition we can write this equation of transmissibility. So from this equation we can find that the value of omega by omega n, or the ratio of omega by omega n, is square root of 12, which is 3.46. From this we can find out omega n is equal to 433.5 rpm, where it is given in the question itself that the value of omega is 1500 rpm. So from this we can also write the value of omega n is twice by n by 60, or twice by 433.5 divided by 60, which converts the value of omega n into radian per second, 45.373 radian per second. Now we have the value of omega n as root over k by m. So this is also equal to omega n. From this we can find out the value of k as omega n square into m, where omega n is 45.373 square into m. Now the important thing is the mass. So here the question says the electric motor is of weight 125 kg and the armature weighs 35 kg. Now this mass m is the total mass of the entire vibrating system. So we need to add 125 plus 35, both the weight of the motor and the armature into this, and divided by 9.81 to convert it into analogous mass, because this k by m, omega n is equal to root over k by m, m is the mass, and the question says the weight of the electric motor is 125 kg and weight of the armature is 35 kg. Hence we divide it by 9.81. So this gives rise to value of equivalent k, or the stiffness, as 33577.3 Newton per meter. Hence we can write the stiffness of each spring is 33577.3 divided by 5. Since the question says that the motor is mounted on 5 springs of negligible damping, so that the force transmitted is 1/11th of the impressed force. So this is divided by 5 and is equal to 6715.5 Newton per meter. This is equivalent stiffness for for each spring. Now the last part of the problem, we know that transmissibility TR is equal to force transmitted to the foundation divided by impressed force, or external force. So from this we can write FTR, or the force transmitted to the foundation, is equal to F into transmissibility. So this F is the external force, or you can simply write it as disturbing force, or the force which creates vibration. In this particular question, our disturbing force is the force due to eccentricity or the eccentric mass of the armature. So it is m naught e omega square into transmissibility is given as 1/11. So m naught e omega square, m naught is the mass of the armature, which is weight is given as 35. So we convert it into mass into E, eccentricity, omega square. So let us convert this RPM into radian per second into 1/11. So this gives the value as 3 Newton directly. So this is the force transmitted to the foundation. This is the total amount of force transmitted to the foundation. Hence, this is the answer. Thank you.